Alright, this is the notes for section 6.6, fitting a quadratic model to data. You'll remember back in chapter 3 we did something very similar to this where we fit data to a linear model. Now that we're looking at quadratics, we're going to kind of do the same process but with quadratics instead of lines. So basically when we say that we want to fit a model to that data, basically we're going to try to find an equation of this form, y equals ax squared plus bx plus c, to the data that we have. To get a specific model for the data, we need to solve for three unknowns. In other words, we need to figure out what is A, what is B, and what is C. Those are really the things that we're looking for. Now, a quadratic regression is just like the linear regression in that it finds a model with the least sum of squares of differences from the given data points to the values predicted by the model. It is not necessarily going to be a perfect fit. Okay, so this right here is the important part, that sometimes our data will be a perfect fit. Okay, and other times it will not. And we need to understand that this is just modeling the data. All right, to fit our quadratic model to our data, there's going to be two methods that we use. One method we can use is this first method, and that is only in a situation where we know the points are on the parabola. So if the points are on the parabola that we're given, we can use this method. And here's the steps that we're going to do. We're going to take the ordered pairs that we're given and substitute them into the general equation. You'll need at least three ordered pairs because there's three unknowns. We're going to write the results of step one as a system of three equations. So once we plug those in, we're going to get three equations in terms of A, B, and C. We'll solve the system, which will tell us what A, B, and C are, and then use the solutions from the system to rewrite that equation for a parabola. And then finally, we want to check our answer to make sure that it's correct. So let's take a look at this first example of that then. So in the example it says a parabola contains the points -1, 8, 1, 2, and 3, 4. Find its equation. Well, one thing that's important here is that we know that the parabola contains these points, so we know these points are right on the parabola. So we can use this first method to go ahead and come up with the model for this. So what I want to do is I want to start by taking each one of these points and plugging it into our general equation. So for instance, if I start with the first one, my y value is 8, and then I'm going to plug in my x value. So if I have -1 squared, that's 1. 1 times a would just be a. I'm going to put -1 in for x here, so that would be -b, so it would be minus b, and then plus c. So that would be one of my equations for my system. So if I plug the other points in, you'll notice that I end up with 2 equals a plus b plus c, and 4 equals 9a plus 3b plus c. And I'm getting that from this point 3, 4. So when I square 3, that's where that 9's coming from. Remember, I'm putting in 3 for x in here. Okay? So after plugging those three ordered pairs in, what that does is it gives me a system of equations that I can now solve. Now generally we would write this on the other side, and when I go to solve this, we'll talk about that in just a second here. But what we want to do now is we want to solve this system. Well, we can solve it using linear combinations or substitution, but really probably the easiest method here, now that we know how to use matrices to solve a system, is to go ahead and do that. So I'm going to write this in matrix form to begin with. So I'm going to have that as being 1, -1, 1, 1, 1, 1, 9, 3, 1. So that would be my coefficient matrix. And I'm going to take that times ABC to get my answer matrix. And here's where I'm just going to put these answers over on the other side, and that would be 8, 2, 4. Now I can use my calculator to go ahead and solve that for A, B, and C. Alright, so I'll label my coefficient matrix as A, my answer matrix as B, then I need to multiply each side by A inverse. Remember, A inverse has to come on the left-hand side. So I have A inverse times A. If I get rid of that, that means I'm left with ABC is equal to A inverse times b. So then I'm going to come over to my calculator. I'm going to put that into my calculator. Here's a inverse times b, and you'll notice that I get 1, negative 3, 4. So let's come back over here now. 1, negative 3, 4. Whoops, wrong thing there. So this would be 1, negative 3, 4. And what that tells me is that a is 1, b is negative 3, and c is 4. So I can come to the step 4 now, and I can say, okay, well then y equals, instead of a, I'm going to put in 1. So it's x squared minus 3x plus 4. And this would be the model for our data. And then to do the final step, what we can do is, and I'm going to leave this piece up to you, is you can plug in these 3 points and show that they make this equation here a true statement. Alright, so for our second method, what we want to do is we want to fit the model by using our calculators to do that. Now this is the way that we would want to use if we don't know for sure whether the points are on the parabola or not. If we just know that it's taking a parabolic form or looking to be somewhat quadratic. So what I'm going to do is I'm going to go to my calculator, I'm going to enter this data into a list and spreadsheet. So you'll just do a new document and then add a list and spreadsheet and put this information in. But what we have to remember is that we are going to make our x value be the years after 1990, and our y value is going to be measured in millions of square meters. So when we're doing this, we have to keep that in mind. So let's label what our variables are first. So I'm going to say x is equal to the number of years after 1990, and y is equal to the number of square kilometers in millions. So if we're trying to find out the extent of the sea ice near the North Pole, what we're going to do is we're going to plug this information now into our calculator. So I come over to my calculator, I'm going to put in a new list and spreadsheets. I want to make sure that I put labels for each of the columns. That's very important. If you don't do that, it's not going to work out. And then I'm entering the number of years after 1990, so 1990 would be 0. And then these values are in millions of square kilometers. Okay, so I have that data entered. The next thing that I need to do is I need to add a data and statistics. So to do that, I'm just going to go to Home and then go to Insert a Data and Statistics, and it will come up kind of like this. And I want to come down here, and I'm going to select my x value. Well, my x value was the year's value, so I'm going to put year down here, and it will organize those. And then we go over here to the y value, and the y value was was area. So now we have that kind of the points in the right place. And the next thing that we want to do then is we go to Menu, and this is just like we did when we did linear regressions. We go to Menu, Analyze, Analyze, there we go, Regression. And this time though, instead of showing linear, which is what we did last time, we're going to show quadratic. And this then would represent the equation that is a quadratic that would best match those points. Now it turns out actually that the points are all right on that parabola. So this is our model then for that data. So I'm going to come over here and I'm going to come back to where I started, and that's the value, that's the equation that I'm going to write, or I can think of that as being a function in terms of x. So if this is f of x, then for part B, when it says predict the extent of the sea ice in February 2020, then I'm going to plug 30 in for x of this equation. So you want to stop the video at this point, plug in 30 and see what you get for a value of your function at that point. So when you do that, you should come up with approximately 12.58, which means that the answer to part B then would be 12.58 million square kilometers. Please don't forget to put million there because that's what y represents.